you agree that from a human perspective, the worst thing that could happen tomorrow is for humans to go extinct?
Oh my God, yes. And it would be so stupid. It would be so unbelievably stupid.
Hello and welcome to A Theory of Everything. I'm Luis Razo, the director of EISM and host of this channel. Today we have a guest who is widely credited as the founder of neurophilosophy, Patricia Churchland. She's an influential and celebrated philosopher emerita at the University of California, San Diego, and famously embodies the idea that in order to understand the mind, we have to understand the brain. Among her many awards, she's a recipient of the so-called Genius Grant from the MacArthur Foundation. Her work is of special significance for this channel because, as you know, one of our central tenets is the idea that physics is the ultimate foundation of everything, including our conscience. In fact, that is the title of her most recent book. You'll see that I had some trouble navigating through this discussion, especially near the end, but I'm happy that we were able to make some progress. If we're lucky, maybe Professor Churchland will agree to return in the future to continue where we left off, because these are important questions with important implications for everything that matters. Thanks for listening, and as always, I've placed a timestamp for the discussion in the video description. Professor Churchland, thank you so much for doing this, and welcome to A Theory of Everything.
It's a great pleasure to be here.
Well, the pleasure's mine, and it really is an honor to finally talk to you. For many, many years, I have been arguing about the importance of physics to my own line of work, management. And most of the time, people respond with many doubts about this supposed connection. You've written a very interesting book on the physical or neurological underpinnings of conscience. And the title of the book is Conscience. And can you tell us a little bit about the background of the book and your career? From what I understand, it's kind of the culmination of your very illustrious career. Can you tell us about your career and where the book fits into that?
Okay, well, there's a lot there in those questions. So I had never really expected to be able to address any aspect of the nature of moral behavior from the point of view of neuroscience. I thought it was probably just way too far off and I'd be long dead before we knew anything. But it turned out that certain discoveries about the nature of social behavior were made in rodents initially, and it was quite obvious that this discovery about rodents and attachment and bonding between males and females, as well as between parents and offspring and parents and kin, that these discoveries were going to tell us something really fundamental about the nature of social behavior in general and moral behavior, what we think of as moral behavior in particular. And as you know, there are really kind of two long traditions within sort of philosophy and science about where moral behavior might originate. And the two traditions sort of go like this. On the one hand, there are those who think that there are laws and that the laws are somehow very general rules, but they apply absolutely. And that's what I call the sort of legal model of morality. And the other view is more naturalistic. And we see it in Hippocrates, the ancient Greek physician. We certainly see it in Aristotle, and even in some degree in Socrates. And here the idea is that we are social by nature. And so we have basically these instincts to be social, to be together, to form bonds, to like each other, to get on with each other, and to cooperate. This was certainly Aristotle's view. And it turned out it was also Darwin's view. And when Darwin wrote in 1871 in his book, The Descent of Man, he asked the question, where does our moral sense or our conscience come from? And, you know, in his characteristically insightful way, he said, and this was just like Aristotle, that it has three components. There is the instinct to be social. There is habits and learning, whereby we acquire the standards and norms of our community. And then there's reasoning, where some of us may and some of us may not reflect on those norms and whether they are suitable for, say, changing circumstances. And that was essentially Aristotle's view. It was essentially Hume's view. So if we think of inquiries into the nature of morality as having the legal model on one hand and the instinct learning skill model on the other hand, the new data about social bonding really, I think, fell on the side of skills and habits and so forth. So very roughly speaking, that's the approach that I find kind of meshes with what we understand from evolutionary biology, from genetics, and from what we understand about how we ourselves operate.
Okay, and how does your book Conscience fit into this scheme, and what are the major ideas within the book?
So let me tell you about the experimental data that made me think that there really was a way that we could ground in neurobiology the basis for altruism. So think first of all about the fact that all animals have to be equipped to see to their own survival. They have to feed when they're hungry. They have to drink when they're thirsty. They have to freeze or to rush away or to attack. They all have to see to their own warmth. So this is fundamental circuitry that is sculpted by evolution and hence derives from the genes, and it's in all of us.
May I pause very quickly there?
However, we also...
I'm sorry,
yes.
may I very quickly insert here an idea that I think is,
yes.
is very interesting along these lines. I definitely agree with you that there's a neurological genetic component to these phenomenon. But there's also something more fundamental, I think, at the physical level. It's called the principle of least action. In fact, one of the most renowned physicists in the world, Juan Maldacena, from the Institute of Advanced Study at Princeton, he calls it directly the principle of maximal life. And even at the fundamental particle physics level, even in quantum mechanics, there is this striving for material things, protons, neutrons, to extend their experience of proper time as long as possible. So I would argue that it's worth thinking about the possibility that it goes even lower than the genetic level, this instinct for self-preservation. Does that make sense, or how do you feel about this?
I don't know. I really couldn't say. I mean, I don't think, for example, that a mountain has an instinct for self-preservation. I mean, it erodes over time, and there isn't anything that it does to preserve itself. On the other hand, it is true that within biology, that there is always a premium on conserving energy. You don't want to waste energy. And it's a very straightforward reason in biology by that. So, and that is that your energy comes from food. And if you're very wasteful, you have to get more food. And I'm going to come back to that.
Okay.
Because in the case of warm-blooded animals, that turned out to be the key to understanding our sociality. But let me just go back a little bit.
Okay.
So we know there are many social species. We know humans are social, marmosets are intensely social, so are wolves. But we also know there is great sociality amongst insects, fish, and so forth. Now, we don't see the complexity of social behavior in, for example, bees. They do have very complex behavior, but it's really tightly structured by their nervous system. They don't have many degrees of freedom. So, and we don't really see much in the way of sociality amongst reptiles. They sometimes cluster in groups, but it's not like, you know, they cuddle each other or they care for each other. We just don't see that. Now, what changed with mammals? And here I'm going to come back to your observation about energy minimization. So about 200 million years ago, something very remarkable happened on the planet, as you know. And that was the emergence of endotherms, animals that could generate their own heat. Now, this was a big deal, ecologically speaking, because it meant that if you were able to do that, if you were warm-blooded, then you could hunt at night. And all the other guys, all the lizards and the newts and so forth, they have to go to sleep. And you might even actually be able to feed on them. So it was a huge advantage. It also meant that you could live in colder climates and you would generate your own heat. Now the downside, and now this comes back to your point, the downside for homeotherms or endotherms is that gram for gram, they have to eat 10 times as much. They have to have 10 times as many calories. And that puts a huge ecological constraint on them. Now, Mother Nature might have found various ways of, evolution might have stumbled on various ways of enhancing their foraging capacity. But one really smart way of doing that is to allow the animal to learn prodigiously. Now, that's a really great thing to do, because if your Mother Nature, if I can anthropomorphize just for the sake of us telling a story, if your Mother Nature, you can wait a long time and put everything into the genes, but it's a slow process. Or you can have the infants born so that they're very immature in their brains, and then their brains tune themselves up to the local environment. And that means that wherever you happen to be, you will learn how to be successful in that environment. So that's a tremendous advantage. And thus we see all mammals and actually all birds, but I'll talk about birds in a minute. All mammals have this thing called cortex. And cortex, it isn't necessarily smarter than anything else. Those deep structures, subcortical structures, in a way, is where the survival mechanisms all are. But the cortex is what grows hugely after the infant is born. And it does tune itself up to the environment. Now, with all of these changes, there's a cost. So what's the cost in the case of having a cortex? Well, I hinted already. I said the animal has to be born very immature so that it's got room to expand, because every time you learn anything, proteins are made to embody what you learned, and neurons sprout. So you have to have room for all of that. So what does that mean? It means that you are very vulnerable when you're born if you're a mammal, and all mammals are. So now Mother Nature has a different problem. So if these are going to survive, there has to have been an evolutionary change such that the mothers did something kind of unusual. So whereas a mother turtle lays her eggs and then scurries off and doesn't really care anymore about what happens, the mother mammal gives live birth, and now all of the circuitry that's there for self-care, seeing to my own food and water and warmth and safety, all that circuitry gets expanded from me to me and mine. And so we see a kind of different way of caring than we see in, for example, fish. So this caring is mediated by very specific neurochemicals. And one of them is oxytocin. And we can manipulate animals so that we can see the role of oxytocin, and also other chemicals like galanin that Catherine Dulac studies. We can see that those are absolutely crucial in establishing and maintaining bonds between baby and mother and baby. Now, it turns out that under certain circumstances, that bonding can extend not only to babies, but to certain special others. And this was the discovery that absolutely blew my mind. It turns out that prairie voles, now there are many kinds of voles, as you know, there's prairie voles, and there are montane voles, and there are meadow voles, and there are all these little plump rodents. Prairie voles live on the open prairie. And when the male and the female meet, they mate, and they're bonded for life. Montane voles, not so. They meet, they mate, and they go their separate ways. He's looking for more action. She's going to have the babies. So Larry Young and various other endocrinologists ask this question: what's the difference in the brain? And it turns out the difference in the brain has to do with the density of receptors in very specific areas for oxytocin. And if you're a prairie vole, you have a lot of those in the reward system. And if you're a montane vole, not so much. And so we could begin to see a connection between maternal infant bonding and mate bonding. And then people began to ask the question, but what about maybe not mate bonding, but bonding with kin, with others in your family, your sisters or your brothers or your whatever, or maybe even between friends. And then of course people wanted to know what oxytocin actually does. But at any rate, the important point that I wanted to make here was really just that the discovery that you can extend caring beyond mother bonding. You can extend caring to kith and kin and friends. That opens the door to answer what Darwin couldn't answer, and that is, what is the biochemical basis for caring, for our instinct to be social? What is it? And I think we have very interesting clues, not the whole answer, but very interesting clues about that.
Well, very good. Very interesting. A couple of questions come to mind as I listen to you regarding those two separate prairie voles.
Yes.
They obviously made, or they evolved in different directions. Do we know the different turnout between those two separate groups of voles?
You mean, do we know their ecological differences? And the answer is yes, exactly. So the montane voles live in rocky mountainous areas, and it's quite easy for them to have a nice safe den way tucked in amongst the rocks. The prairie voles live on the open prairie. So they live in communities. So it's not just a single mom and her babies. It's the whole group kind of living in a general area. And the male not only is long-term bonded to the female and vice versa, but the male takes part in rearing the pups and in protecting the pups. So he protects the nest against intruders. Of course, as you would imagine, predatory birds are the main problem for the prairie voles. And the male prairie voles take a really important role in protecting them. So you can see why the oxytocin story would be selected for over evolutionary time for animals who were living in the open prairie. Now, there will be a somewhat different story for why wolves, for example, form these very strong packs. They too have monogamous pair bonding for life. The male also takes part in the rearing of the pups. And within a pack, there's always only one breeding pair. If the female dies for some reason, then one of the other females will go into estrus. But there's always only one breeding pair. But you can understand that for predators that are like wolves, it's hugely advantageous to live in a pack. A lone wolf, it's pretty hard to, a lone wolf can't bring down a deer. It can maybe, you know, manage with a few mice or something, but to really thrive and flourish, they need to work together. And so you can see why evolution selected for that kind of group formation.
Very good. Well, a couple more things come to mind.
Okay.
Returning to the concept of survival.
Yeah.
Can we say that, for example, the different voles, the prairie voles and the mountain voles, do we know anything about how fit they were to survive after this oxytocin development? Were they more fit?
They both do very well in their particular ecological conditions. They do extremely well. Just as the wolves. I mean, you know, unless humans are out there gunning them down, wolves do extremely well. And but you know, it depends on what the ecological pressures are. So, you know, cougars are loners, and but they have a very different physical body. They climb trees and they can leap down on a deer, and they're huge, and they're much larger than a wolf and much stronger than a wolf. And so they can be loners and be very successful. And the mom keeps the babies up in the tree until they're mature. So I think we can understand the sociality being advantageous in the case of wolves and not really helping much in the case of cougars. Now, humans, of course, we want to ask the question about ourselves, but, you know, why is it so advantageous, or what were the advantages for hominins roughly 2 million years ago?
Yeah, good question. I was going to say that I was going to ask the next question is, how does this apply, or how can we apply these ideas to humans and human sociality, and in particular, some of the difficulties that we're having today, concretely in the Western world and Europe and the US, regarding the social disorder and the role of conscience in all of this. Can you connect the two, or do you connect the two?
Well, yeah, so there's kind of three questions there. What do we know about the ecology of hominins roughly 2 million years ago? That's one thing. and maybe that's where I should start. I mean, as you know, of course, we are not the only hominins, and Homo erectus was around for about 1.8 million years. And Homo erectus clearly also lived in small groups, and it was almost certainly advantageous to have these bonds between individuals in groups and to cooperate for such things as scavenging and hunting and taking care of each other and so forth. So for the same reason that it's advantageous for bonobos and chimpanzees and marmosets to live together in groups, and baboons. I mean, baboons are wonderfully interesting social mammals. So I think that we humans clearly have a very deep social instinct. We like to be together. We form these very strong bonds within family and within community. And we are willing to incur a cost to ourselves in order to help others. People do that in small communities all the time. And of course, sometimes the costs are really enormous, and people, not everyone, but some people are certainly very willing to incur those kinds of costs, especially if it involves the defense of the group against attack. Attack by other animals is not surprising. I mean, if you're a lone human, if I'm a lone human in northern Manitoba, I'm not going to last very long. Why? Because there's a lot of wolves there, and I'm just easy pickings for the wolves. Just no problem. You know, unless I have a gun. But I mean, you know, 200,000 years ago, we humans, Homo sapiens, did not have such things. So it's obviously very advantageous to live in groups, and that means that certain feelings and responses, feelings of attachment, of bonding, of care, of willing to help, willing to cooperate, and trust develop in us, as they do in wolves and chimpanzees and baboons. Now, the other thing I think was part of your question is, so what do we know about humans and their oxytocin levels? And here, you know, this is one of those wonderful places where you can only answer a question if the techniques are available to take the appropriate measurements. We know how to measure oxytocin levels in a rat or in a prairie vole. We know also how to stain the brain of a prairie vole to find the receptors for oxytocin and see where they project to. You can't do that in a human. So at the moment, to the best of my knowledge, there are only 2 cases that have come to autopsy, both were females, where we were able to look for density of receptors in the reward system, in the nucleus accumbens, which is part of the reward system. And both those 2 cases showed a high density of receptors, but that's N of 2. And almost certainly, biology being biology, you know, we have a bell curve and fat tails. So almost certainly we need a lot more data before we can say anything very specific. Now, the other thing is this. It isn't, you'd think, well, look, if oxytocin is such a big deal, why don't we just give it to people and see how they behave? Because we know when you inject oxytocin directly into the brain of, for example, a vole, that it does change their behavior. It accentuates their sociality. It reduces levels of stress. Well, we can't put it directly into the brain of a normal, healthy human. So what do? So people thought, well, look, you know, cocaine, you shoot it up the nose, it gets into the brain. Maybe oxytocin does too. Too bad, doesn't it?
Okay.
As you know, there is this kind of amazing thing in the nervous system called the blood-brain barrier, which is a membrane that exists between blood vessels and nervous tissue. And many things will not cross the blood-brain barrier. Oxytocin will, but it's difficult. It has to have active transport of little transporters, and so it's rate limited. So
Okay.
on the other hand, there were all these experiments showing that if you spray nasal spray oxytocin up the nose, it does change human behavior. So some of those experiments, I'm bound to say, were not very good. They didn't have very many subjects, and they were very poorly controlled, and it was almost certainly artifactual and blah. Other experiments kind of look better, but then people say, well, how does it get into the brain? And one theory is, well, it goes up through the olfactory bulb and somehow finds its way. At the moment, I think the answer is not known. And so we have to be kind of reserved. The answer will be known at some point, but we don't know yet.
Well, you did this with the prairie voles, and
Yeah.
can we do something similar with our current situation?
Yeah.
For example, we have, every person has a conscience, right?
Yeah.
In some sense, can we think that nature itself is also working through our conscience and our oxytocin levels, natural oxytocin levels, and different neurochemical processes to help us adapt to survive? Or do you think that's something that doesn't apply today?
Well, I don't know. There was something I was going to say there, and I've kind of forgotten.
I'll give you an example. I'll give you an example.
Yeah.
In fact, it's a very real example, because there's controversy now about the traditional nuclear family. So
yeah.
We obviously have survived for many years, and with the traditional family, mother, father, and children. Now there's some pressure, environmental pressure, from some groups to do away with this.
Right.
Is this an element? Is there a neurological foundation to this? And can we expect different outcomes from? Obviously, we can expect different outcomes, no? But can you comment on this? How do you feel about this?
Well, we certainly know that in all mammals and all birds, that the bonding between parents and offspring is hugely strong. I mean, and that's certainly the case in humans. There was one thing that you did say, though, that I just want to correct. It's a very minor correction. You said, well, we all have a conscience. Well, of course we don't. This is biology. There's always a bell curve. There are those folks, and we know one very well in the US. There are those folks who have no conscience at all, and we call them psychopaths.
I see, okay.
And they don't care. They know how to manipulate other people. They can be very narcissistic. They can be very engaging, but they do not care. So, but nevertheless, your point is well taken, that by and large, that is, the big part of the bell curve is where most of us reside. And most of us do form very strong bonds. It can be to friends, but always, almost always, it is to children. Now, there's another caveat there, and that is that women who are drug addicts have such a messed up reward system that they often do not care about their offspring. And of course, health workers are very concerned about this because, well, for obvious reasons. But to get back to the main question that you're asking is this really, really deeply instinctual, this connection between, let's just say, mothers and babies, such that if you try to revise it, you're going to cause problems? My hunch is that it's very deep and very basic. And even amongst the hunter-gatherer societies that still existed within the last and this century, we know that community is extremely important, that nuclear families are extremely important. Now, I mean, maybe the norm revision people would be happy if several nuclear families lived together in one house. I mean, after all, amongst the Inuit in the Arctic, they used to share, you know, 3 or 4 families would share a great big igloo, and you know, the kids were all in there, and the parents and so forth. But it strikes me as something that you don't twiddle with just because you think it's a good idea. I mean, there are kind of norm revisions that have happened in my lifetime. The attitude towards homosexuals is a really big and important one, but also the attitude towards driving drunk. When I was a kid growing up in you know, a small town, every once in a while there'd be some, you know, 18-year-old kid who would drink about 12 beers and then crash into a telephone pole, and people would just say, ah, well, you know, he's dead, but you know, boys are boys. And then when Mothers Against Drunk Driving really made a case that this is not funny, this is not amusing, this is tragic, not only for the kid who kills himself, but for the other people that he kills, the attitude towards drunk driving completely changed. Over a 20-year period, it doesn't ever change overnight. But over a 20-year period, it did. So we know there can be revisions of community norms or community standards. But with regard to the nuclear family, I think we're talking about not something like finding drunk driving amusing, but something much deeper. I think it is the sort of fountainhead for the instincts of sociality. And I would be very careful about messing with it until I was really, really sure that I knew what I was doing. And, you know, there's lots of folks out there who sort of get an idea about something, and then suddenly it becomes the whole focus, and they become kind of, well, they kind of go nuts over it, so to speak. And I don't know whether this is a case in point or not. But I've seen in my whole life enough of those kinds of things where these enthusiasms suddenly just take over. And I'm not real happy about those kinds of enthusiasms. I'm very skeptical.
Okay, well, very good. Well, that brings me to another, maybe the heart of the matter from me, and I suppose for many others. So conscience and the connection to free will. So if we come to, let's not get specific. If we talk about 2 different behavioral or cultural options, option A and option B for a society, part of the society wants option A, part of the society wants option B. Right. Conscience plays a role in the decision-making. Say again?
Often both, yeah. I know that's the hard thing about social life, is that people can have deeply felt and well-reasoned differences of opinion.
Okay, so here's what I want to get across. You have these two options. Nature, in some sense, is opening up those 2 options for the 2 groups of people. You can do option A or you can take option B. They're both listening to their consciences in different ways. And there's going to be different physical outcomes.
I see, yeah.
Right? Based on those 2 options, right? Yeah. Does that seem logical?
Sometimes that's true, yes. Sometimes it's true, sometimes it's not. Or if there are differences in consequences of the 2 options, they're on such a long time scale that it doesn't have the impact that you might think. I mean,
that's a perfect idea. I really like that one. I think a part of this, or an important part of this whole topic, is the issue of time frames, right? Because we're alive as humans because of a very, very long time frame of nature offering different options to our predecessors,
Yeah,
right?
yeah, 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 yeah,
And so some of our predecessors, or all of them, passed away or died. They died off,
yeah,
and we survived. This
yeah.
process must be still taking place, correct or incorrect?
Well, there's so many of us, and there's such variability in ecology, and the time scale is so short. Like, I can't honestly think that within my lifetime it's all that likely that there are genetic changes that are going to enhance the survivability of a subset of humans. But having said that, of course, we all know that lots of humans will make really, really, really dumb decisions. And as a result, either their survival or that of their children is imperiled. We know that. Now, Mother Nature doesn't ensure that if you make good decisions that enhance your survival and your flourishing and that of your children, that you will, in fact, pass on your genes, because, you know, there could be a volcano erupt. But certainly you have a better chance if you make certain kinds of decisions rather than others. But it's complicated. So let me give you an example.
Okay.
And this bears upon your thoughts about free will. So early, long before mammals, there is almost certainly circuitry for very limited kinds of self-control. That is, where you don't panic in the face of a problem, that the animal manages to deal with it in a survival enhancing way. Now, we know, for example, let's go to mammals. We know that rats have the capacity for self-control. And here's how you test that. So you set up a food tower, and it has a little bar on it, and when the rat nose pokes, it gets a pellet. Well, that's dandy. Now you put in a second one, and the rat explores, and it discovers that if it presses the button on the second tower, it gets 5 pellets. Well, now what you do is, for each time the rat has one chance at one food tower, and then the trial is over. So now here's how you test for self-control. You put in the 2 food towers, but in the high-paying one, you insert a delay. So the rat can press it, but it has to wait 3, 5, 10, 20 seconds. Now, some rats can delay gratification for the greater value, and some can't. And some go to the high-paying one and just patiently wait, and others go and look, and they think, oh, no, no, and then they go to the low-paying one, and they end up just getting one. So there are other tests also for self-control, and we have a good idea where that circuitry is in the subcortical and cortical structures of the brain. Now, deferring gratification in a rat with a food tower is not completely unlike how humans defer gratification, right? They think, well, you know, if I just buy a box of cornflakes, I can eat those without having to cook. But, you know, in terms of value, it's way, way, way more expensive than buying a box of rolled oats, which takes a little longer to cook, but is better for me and costs 1/100th of the price. So humans can do it, and lots of humans can do it, and some humans can't. So you might ask about the rats. Well, is it ever a good idea to lack self-control in the way that some of the rats do? And the answer is there may be conditions, ecological conditions, such that that is actually favored. And that's why we're going to see a bell curve. Some rats are going to have tremendous self-control, and some are not. And because we're talking about long evolutionary time and many different kinds of conditions, sometimes the rat that lacks self-control is going to do better than the rat that hasn't. And maybe that's true in humans. I don't know. Maybe there is some advantage to lacking self-control. Maybe you're more interesting if you're a man. Maybe you're more interesting to females or something. I don't know. But we can't assume that self-control is going to be evenly distributed throughout the population, or the capacity for it.
Okay, excellent. Yeah, I think the concept of survivability is so important on so many different levels. Now, even for example, in management, one of the biggest mysteries has been why some companies survive and some do not.
Absolutely.
And I think it's such an important principle. And I think it's also relevant for the survival of countries. I think if you're not following the right path, if you follow the wrong ideas, right? And ideas are ultimately physical. Yeah. Their foundation is physical. If you have the wrong ideas, then your country or whatever project you happen to be having to venture on is going to suffer the physical consequences of that route. That seems like such a logical thing to me.
Yeah, I mean, I think that people have known that certainly since Aristotle. I mean, they know there are better and worse ways of organizing a community. And of course, they had Sparta. The Athenians had Sparta to compare with, and so there is no doubt that there are better and worse ways of organizing a community. And as you know, I think one of the issues within the US has long been the issue of accessibility of healthcare. And the cost to the community as a whole, or to the country and the economy as a whole, when you don't have accessible healthcare and you have a pandemic, the cost is huge. And people have been telling us this for years. And many people don't really care because they're very short term. They're not thinking of, oh, we'll never have a pandemic. You're not thinking in the long term. But the economic consequences are very clear to us right now. That people can't afford healthcare, so they know they're sick. They go to work anyway because they have to. Well, how dumb is that? So in any case, I totally agree with you. There are better and worse ways of organizing things. And sometimes what we have to realize is that to be pragmatic about these things is wiser than just taking a moral stand and saying, this is right. That you can't divide social appropriateness of rules and norms. You can't divide that from the pragmatic. The pragmatic is really important.
Yes, I would say it's the most important. No, I think that, especially when it comes to survival. I mean, ultimately what we want to do is survive. In fact, that brings up another very important point that I wanted to stress that I think is very much in line with what we've talked about. We've reached a point as a species where our survival is literally threatened with war and various other dangers. So this, I think in some sense, our conscience, right, is calling us toward that survival instinct. We want to survive. The question is, how do we survive? We have so many options open to us. How do we survive? And that reminds me of another point. For example, in the last, since the scientific revolution, and more recently, since the economic boom of after the Industrial Revolution, we've created this civilization of comfort and economic progress. So again, the survivability, how we're going to survive. This sounds like a good path. Okay, let's create a lot of economic growth. Let's be really happy, a lot of technology, but then we don't have children, and we
Yeah.
basically, we don't cease to exist.
It is a very, very interesting question. And, you know, as I think you kind of indicated earlier, we know that it's very important to see certain problems as practical problems and try to understand what policy might be the most effective. It's just that it's hard devising policy. And it's hard because, well, first of all, you know, you have to look into the long term, and often there are so many uncertainties, you just don't know what to think. But on the other hand, you also have to sell those policies, because policies that are just imposed on folks often don't work because people don't like to have stuff imposed on them. And so I think it's hard, but the other part of it is that it's so important to have appropriate policies, but most people don't think of it as very sexy or theatrical. They don't want to have to figure out stuff like that. They call it the deep state. And you know, oh, that's just, you know, bureaucrats fussing around. But if you don't have decent policies, you're going to pay the price. There is no question. And the US right now is paying the price.
Oh, very good.
And how steep that price will be and how long it will go on, we don't know. But I mean, here's the thing. You might think, well, Mother Nature should just, you know, snuff those guys who don't wear masks, for example. But it doesn't really quite work that way. The kids who go to the bars and don't wear masks, they aren't the ones who are going to die. But the old, you know, their grandma and grandpa that they visit, they are going to die. Well, they'll feel a little bit bad, but it's not like Mother Nature versus a really unpleasant consequence on the people who didn't wear masks. So,
well, I would argue in this case, I would argue that, okay, on a short term, that's definitely true. But I would argue that it's an open question whether in the long term, for example, in 1,000 years, that person who decided not to wear a mask, there's certain neurochemicals and genetics working in that person. I think in the long run, there must be a difference between maybe not mask wearing, but behaviors that contribute to long-term genetic survival in terms of your line of descendants.
Probably, but then we go back to the rats, you know, so you still have a bell curve in self-control in rats. So you would think that over evolutionary time, if lack of self-control was so bad that you wouldn't have a fat tail up there, but you do. And I mean, this is a very short-term thing, but I do not see in my lifetime an expansion of the numbers of people who have self-control versus those who don't. Save in one case, and that is with people who become addicted to opioids. I don't know whether that has anything much to do with self-control mechanisms or not, but they're dying at an alarming rate. That is one case where, let's assume for the sake of argument, something that we do not know, and that is that there is a relationship between poor mechanisms of self-control and opioid addiction, and they are dying. That would be a case that speaks to the hypothesis that you're concerned with. Yeah.
Okay. Well, final question. You mentioned Aristotle earlier, and Aristotle, his explanation for causality was that there's 4 types of causes, and one of them was final causality. So as I listened to you and I read your book, I couldn't help but think that in some sense, nature has final ends. Do you think that this is absolutely untrue, or how would you, because you anthropomorphize.
Anthropomorphize,
Forgive me.
yeah, that horrible word again.
Yeah, that horrible word.
Yeah.
Why not accept the possibility that nature has goals?
Well, because it doesn't really. I mean, what's the good of it? Um, it it just is what it is, and there's a lot of blind forces working there. And if certain mutations work in a certain ecological condition, then the animal will thrive. But then the condition changes and it dies. So I just don't see the point of saying that. And I think there is a point to not saying it. And that point is that we don't really want to confuse people. It's not a good idea. I like to sort of pretend I'm Mother Nature and this is what I do and so forth. And that's because it's shorthand for a very long-winded part of the story that mostly I can assume people understand. But when I'm talking to my friends down on Dog Beach, for example, I don't do that because I don't want them to think that somehow Mother Nature has intentions and that amongst their Mother Nature's intentions or goals is the survival of people like me. And that's, you know what I mean? There's always this temptation to think that me and mine are privileged because we are special. And once people start thinking like that, trouble starts. And so I consider it dumb luck that I'm here on this planet at all. And why not? Other people I know like to think that they are here because God really wanted it to happen. And sometimes they might put in a different expression. Mother Nature really wanted it to happen. That's a delusion. It's a total delusion. You're here because of pure dumb luck.
Okay. Well, a question along these lines. Would you agree or disagree, and this is the final question, would you agree or disagree that from a human perspective, the worst thing that could possibly happen would be for the human race to go extinct?
I guess. I mean, I think that in the long haul, it's probably likely. It's hard to know what could be the cause. I mean, I'm fascinated, of course, by the fact that the Neanderthals, which were really hominins that were very successful in very many respects, and it's clear that they had some linguistic capacity and they had artistic functions. They buried their dead. I bet they weren't very much different from us. And they're gone. I don't think I would not be happy if humans became extinct. But, you know, I don't fret about it either. I do know that there are local policies that I need to be concerned about in order to see to the future of humans, policies having to do with climate change and so forth. That I really care about. But, you know, in a million years, if there are no humans, is that going to make me lose sleep? Well, maybe I'll shed a brief tear, but, you know, it doesn't grip my emotions in the same way.
Okay. Yeah. Actually, the question was more directed toward tomorrow. Let's say tomorrow there was a nuclear war. There was a nuclear war and everybody died. Would that be?
I think that, of course, it would be terrible.
Okay.
It would be insanely awful.
Okay.
That's a terrible thought.
I think we all agree about that.
Oh my God, yes. And it would be so stupid. It would be so unbelievably stupid.
Yes.
But you know, there are certain folks in power who are unbelievably stupid.
Yes. Okay. As a final note, I'd like to recommend our listeners to read your stuff. Conscience is a very interesting book. And where else can people follow you or learn more about your activity?
Well, I have a website, patriciachurchland.com. And I have lots and lots of papers on the website. I think essentially all my publications and many of my podcasts are there, and they're all downloadable. So people can go and forage.
Okay, wonderful. Well, thanks again for your time. I really appreciate it.
You're so welcome. It's been a pleasure.